What is up, guys? I had the worst, I guess you could call it a tension migraine, I guess, of my life. About the last 4 days, 3 days, 4 days. It was awful. Completely awful. Couldn't even vape for about 48 hours. I was just sick, deathly sick. Awful. Of course, I'm back to enjoying myself again now. So, got the garage readjusted a little bit here. Still haven't adjusted all the lights out here. Can't hardly see without that thing in the background. So if it bothers you, sorry. I don't have enough light out here as it is. Got a bunch of fluorescents that the previous, I don't know what you call them, people who lived here previously installed and never hooked up. So that'll be a project for me at some point. I intend to use these components to test a hookup for those, as well as for my biggest LiPo box. This sumbug is like a 180 amp MOSFET. It's rated for 10 volts nominal. 10 to 20 volts is actually what the spec sheet says, but about 12 volts thereabouts is what it wants at the gate for optimal efficiency. That's a mean sumbug. I attempted to use it in my 4.2 volt LiPo box and it was a terrible failure. 4.2 volts is not enough to get that fully saturated. I mean, it just basically was a resistor. I got like 2.3 volts max out of it, and that was working as it was supposed to. But anyways, back to these. All Radio Shack. I'll show you the parts. I'll let you guys guess, and then I'll tell you what it is anyways. 555 timer. Some very simple low power diodes, 100k ohm potentiometer, and a couple of little capacitors, ceramic capacitors. They will power this. There will be 2 capacitors, 2 diodes, a potentiometer, and the 555 timer. And that will be approximately 144 hertz pulse width module, PWM. Cost me $9 at Radio Shack. Probably could have got it for half that off of Mouser, but I'm impatient. I have no idea what the efficiency on this thing is going to be. It's the first one for me to actually fully build from scratch. I have made some voltage regulators in the past. I actually got my computer up and running and I was going to pull it up for you guys, but I can't seem to remember what it was because it's actually on the phone that I'm using to record. But I've double checked the math. It should be about 144 hertz on the cycle rate at full power. I'm really looking forward to trying it. I'm going to put it on the 12 volt LiPo box simply because I can use this on it and this should perform extremely well. This is only the first half of what I intend to do. I was going to upload another video and wound up not doing it because I screwed the video up, but I'm going to build an AC inverter, a full H-bridge inverter that runs off the pulse width module. It will produce a modified sine wave, so you'll have the square wave that the pulse width module produces, 0 volts, 12 volts, 0 volts, 12 volts, and you just adjust that pulse. That, I'll have to set it, and then that will feed a full H-bridge of 4 MOSFETs, 2 P channel, 2 N channel, that will oscillate between positive and negative voltage and give me one hot leg at 12 volts. I'm not going to boost the voltage. That has been a huge problem trying to get the circuit designed properly because I can do it myself, but then I don't have anything to test the circuit before I build it. And I don't really feel like frying myself with AC voltage, even if it is only 12 volts. And of course, every inverter on the face of the planet that you can find online has a freaking transformer built into the circuit. So I've had to find a way to cut the transformer out. I think I finally got it figured out. But anyways, the pulse width module feeds in the square wave at a set frequency. The H bridge oscillates between positive and negative voltage. So rather than a standard square wave from 0 to 12 volts, 0 at the bottom, 12 at the top, you get 0 volts, 12 volts at the top, and then it drops back down to 0 for, I don't know, like 5 nanoseconds, and then drops down to 12 volts negative 12 volts, back up to 0, positive 12 volts. So you get, it's not a nice pretty sinusoidal waveform, but it is pretty close. And for the e-cig, powering a freaking heating element coil, it's not going to care. It's not going to hurt it one bit. I have no idea if it's going to do anything for it. I don't know if the AC voltage is going to operate any better at all. It's actually probably going to limit my wattage quite a bit more than just running the pulse width module, because I'll have to use the P-channel MOSFETs, and they're not nearly as powerful. But it's not going to kill me. Got me some great Fanta. Yeah, that's basically all there is to it. 7 parts to make a pulse width module, and that's about as simple as that gets, but that's pretty damn simple considering. I guess 8 if you consider the MOSFET, which isn't necessary. It's just to power higher I cannot speak tonight. Higher amperage. I need more vape. Because bigger is always better, right? I lost the damn cap. I'll be right back. Found it. Not the cap, the tip. I hope this cotton's still good. I haven't touched this thing in probably about a week. Charged the battery up last night. It takes about 12 hours to charge this thing with my current charger. I'm going to have to build me a better one. Ooh. Spitting that juice everywhere. Damn it, that's good. So, yeah. That's pretty much... I guess this is just a check-in video. Oh, I rigged up one of my old computer fans as a discharger for my LiPos. Every once in a while I like to discharge them down to minimum voltage, not using the e-cig on a low amperage discharge, and get them down as low as I can get them without damaging them, and then give them a full 100% charge back up to full capacity. I don't do it very often, usually just kind of when I decide to and I have time. I don't know that it does any better, but it gives me something to do. And this is actually, it's actually operating. This is my current LiPo charger. Plugs into both the Dean's and the balance charger. Still not sure why it needs that. It's been explained to me, but all my previous chargers have only used the balance charging port. This one doesn't do anything different. But this LiPo, I left it on the fan for about 3 days. Completely forgot about it. It's like a 3-inch computer fan, one of the ducted fans, and it was discharged down to 3.3 volts. The entire battery. All 3 cells together was 3.3 volts. It was like 1.1 volts per cell. And it was swollen, and I knew it was trash. So I hooked it up to my 15 volt 1.5 amp adapter to see if I couldn't blow it up. Gave it about 15 minutes on that and had it up to 9 volts and hooked it up to the charger. It charged back up. I let it sit for about a week to make sure it wasn't going to do anything, and the swelling went down. Surprise, I've never had a lipo do that before. I have discharged many beyond that point. Discharging them on that stupid fan, I've got to set something up so it doesn't do that. But anyways, I knew it was trash, and it wasn't. If any of you guys know why my lipo's swelling went back down after I got it up to full charge and then let it sit, please let me know why, because any tech forum that you go on for that crap, they just give you superstitious crap. Nobody ever wants to give me solid facts, solid reasons why. I research it, I can get a pretty decent understanding of why it happens, but I never can get actual, this is what it's doing, this is why it swelled up. I know why it swelled up, because the battery discharged and all those chemicals decided they were almost about to blow up. But I don't know why the swelling went back down. I've never had one unswell on me. Usually they just keep going until they blow up. I was really surprised after I pulled it out of the steel box that it was in that it hadn't continued to swell. It was a big surprise, but it tests good. Still handles full current without any issues. Still doesn't get hot. Everything I've tested it with seems to work perfectly fine. So I'm going to continue with the pulse width module. I hope to have that finished tomorrow and get a good build on the big 12 volt box again, and I have another video for you guys with that. If that works, I'm going to put one in my 4.2 volt box. Why, you ask? Why would you need to step down 4.2 volts? Well, because I can. There is no other reason. I really just want to try it. Basically because I want to get me some 14 gauge or some 16 gauge Kanthal and put it in here. And I know everything in this box can handle it just fine. That's not the issue. What this is built for was for just ridiculous amounts of power handling. But I want to be able to adjust it. I want to be able to turn it down to 2 volts with a freaking 14 gauge wire in it and still get something out of it. Probably won't work. I don't know if the pulse width module will operate that low. The whole advantage of the pulse width module on the MOSFET is it's still feeding the MOSFET with full power. The MOSFET doesn't care. But if you guys have any questions, if you have any answers, answers are awesome. I love answers. I do not have nearly enough of them. Feel free to contact me on here. Been trying to get back to everybody as soon as they comment, usually, when I remember. If not, I will post a link to my Facebook group, APV Customs. Yeah. I guess I can try to give you guys some clouds. I don't know how well it's going to work. Anyways, vape on, guys.